Hi everyone. So I got a question here by email, and so I want to sort of see if I can address it because I'm posting this because I imagine other people may be having a similar sort of question. And here's the question. Okay, the concept of the addition rules I think in the rules of implication are confusing me. The first problem you worked out in the video for this section is if A, then B, 2, B or C, right? Then D and E, right? Close parentheses. Line 3 is A, and then the result we're looking for is D. Okay. Now, you use addition in the fifth line when solving the problem, but I don't understand why. Okay, let's redo this problem here and maybe see if I can explain it better. Okay, so here's the problem here. Now, over here we'll write down some of the rules we're going to use. And since this question in particular is about the rules of addition, let's write real quick, sort of lay out what the rule of addition looks like. The rule of addition says that if you have P, you can always add something with the disjunction, that's called adding. You can always add a Q, okay? So this is what the rule of addition says. If you have this premise, you can conclude this, where you can literally add this, and literally you could just make this up. You can pull it out of thin air. You can just make it up, whatever, right? This Q. So why is that the case, right? Because you're confused. Why is it that you can just add this, and why would we want to do that? So let me see if I can make sense of how this rule is actually valid, right? So let's remember one thing here. Remember, because this when we add something, we use a disjunction, right? So adding with a disjunction. Adding with the disjunction. So let's remember, what is the disjunction rule itself? And this goes all the way back to propositional logic, the basics of doing truth tables, right? Remember, the rule of addition says that if I have P or Q, right, and then I did a truth table, I would have true, true, false, false, true, false, true, false. Sorry, this is crooked. Okay, and then if I was actually going to build out the truth table, let me change the colors here. Which values would be true for the operator of disjunction? This would be true, this would be true, this would be true, and this would be false, right? This was basically the operational definition we gave for the truth functionality of this, right? But notice here, the rule of disjunction, it's always true unless both are false, right? Which means that disjunctions are true, right? Unless both variables are false, right? So let's see here. Don't know how to make a new page, right? So okay, so they're always true unless both the variables are false. Because see, this one's false and this one's false. That's what makes this false. Now, when we're doing a proof, right? Let's remember when you're doing a proof, right? You're starting off with these three things. Because remember, a proof can only prove validity, but not invalidity. It can only prove valid arguments, right? But you can't prove an invalid argument. So that means that all of the arguments we always give you in these problems are going to be valid arguments because you can only make proofs for valid arguments. We want you to practice making proofs, and that's what you have to do. So that means that we're assuming that this argument is valid to start with, right? And that means that which means to say that this is a true premise, that would mean that, right, this is actually true, line 1 is true, line 2 is true, and line 3 is true, and that it's also eventually going to be true that you can get to D. So, but by assuming that, that means we're assuming that each of these premises are true. Because remember, a valid argument is one if it has true premises, the conclusion follows as necessarily true. So we're assuming that these are all true, right? Okay, I can't do that. We're assuming that these are all true, right? So now why does that matter? Because that means that if I add a q, right? So when I go back to the rule of addition, if I take this premise, let's say I take this premise A, right? And I want to do an addition. Let's just say I want to add B. Am I allowed to do it? Yes, you are allowed to do it. But the thing is, what if B is false? Right? Because you might say, well, what if B is false? The answer is it doesn't matter because A is still true, right? Because A was here, right? So even if the Q or the B in this case is false, it doesn't matter. It's still true, which means you can still use it and it's still a valid argument, okay? And that's ultimately the question of why I can do an addition. Now, you may be asking a more specific question, though, in which may be, okay, I see that you did the rule addition, but how did you know how to actually do that rule? How did you know when to actually perform that rule or that thing? So let me erase this. And let's do this problem here, okay? Let's get our color back. Okay, so this is line 3. So let's do the problem here, right? Well, I need to get to D, which means, right, here there's thing, but the D here is stuck behind a conditional, which means I'm going to need a modus ponens to get here, right? And you can see here I need B or C to do that. There's no other C in the problem, but there's a B. So as you probably see quickly, I can use A here from line 3 to and line 1 using modus ponens to conclude B, right? So that's line 1 and 3 modus ponens. And then line 5 here is the question is I need B or C, but since C is not in any other premise, the only possible way I can do it is to go to this rule of addition over here. So that's why I add B in here. Maybe I'll change the color here. I'll put B or C. And the reason I'm using the green here is because I'm just making up the C. What if the C is false? Let's assume the C is false, right? And if you did, and then you eventually did a truth table of the full argument, you would discover that there's nothing wrong, right? That it still is valid, okay? So let's go here to number 6. Now that I have B and C, right, essentially I have the same thing here in line 2 that I need to get D and E. So that means that I can use the rule of modus ponens again, except this case I'm using lines 2 and 5 for modus ponens. And this was line 4 addition, right? And then number 7, I want to get D by itself, so I can using the rule of simplification. So that's line 6, simplification. So hopefully you see, number 1, why it is you're allowed to add things like, why it is you're allowed to just add random things. Because remember, this is a powerful tool. You can add anything you want at any time. But the problem is, as soon as you add it, you probably make it more difficult for yourself unless you add for particular reasons. So you're only going to really add, and the reason I knew I needed to add was because I needed this C, but the C was nowhere else to be found, right, which told me to add it. So hopefully that explains why you do the addition in this problem, but also, more importantly, I hope it explains why you're allowed to actually do this, okay? Thank you very much. I look forward to hearing other comments or questions.